Thank you for inviting me here as well. I'm going to present my PhD project, which is called EEG Markers of Cognition and Bipolar Disorder from Wakefulness to Sleep. And the short title is Sleep and Cognition and Bipolar Disorder, which is, I think, what's written in the program. I am at King's College London and doing a collaboration with Technische Universität Dresden, and I'm supervised by Dr. Philip Ritter, Dr. Becky Strawbridge, and Professor Alan Young. First, I would like to give you some background on cognition and bipolar disorder, because loads of people with bipolar disorder experience persisting cognitive impairments. For example, they might struggle with their attention, memory, or their executive functioning. So, for example, they might struggle to focus on a book or go grocery shopping because they might forget what they wanted to buy, or they might struggle using public transport because it is just a bit overwhelming to plan which bus to take when. And this is the case for loads of people even in remission, so not when they're currently depressed or manic, but also when they're euthymic. And you can imagine that this can be really disabling and has a direct impact on their psychosocial functioning and quality of life, and that this may even pose a risk for effective relapse. So it's really important to tackle these cognitive difficulties and improve them. And this is basically the overarching goal of my PhD project, to enhance the understanding of cognitive difficulties in bipolar disorder. And we are doing this through EEG. Because EEG is a direct measure of neural activity with high temporal resolution, it gives you kind of like a direct insight into what's happening in the brain. So when you combine EEG with cognitive measures, you can understand when the cognitive processes are disrupted, and this can then shed light on the biological underpinnings of cognitive deficits. So, for example, which neural circuits are involved or which neurotransmitters. And ultimately, this can inform treatment, like pharmacotherapy or even psychotherapy. First, we worked on a systematic review, EEG markers of cognitive performance in bipolar disorder, where we looked at wake EEG markers. So basically, we looked at associations between any EEG measure with any cognitive task, assessing any cognitive domain. This is the flowchart of our review. We started with 1,256 records to screen, and after title and abstract screening and full text screening, we ended up with 16 articles describing 15 studies. Unfortunately, the correlations that were reported were quite heterogeneous, so the methodology was very different. They used very different cognitive tasks, very different EEG measures, and also the sample was quite heterogeneous. So obviously everyone had bipolar disorder, but sometimes they were depressed, sometimes manic, sometimes euthymic, sometimes it wasn't reported, sometimes they were medicated, sometimes they weren't. So we couldn't do a meta-analysis and just did a narrative synthesis instead. We grouped all the cognitive outcomes into the following groups: attention and processing speed, working memory, episodic memory, executive function, and intellectual capacity. And we usually did that according to what the authors reported. So, for example, when they said something like, "Oh, we did a Stroop task assessing attention," then we would group that correlation into the attention and processing speed. Sometimes they didn't report which domain they were assessing, in which case we would just assign the association to one of these groups to the best of our knowledge. And same with the EEG measures. Here we had ERP measures, spectral measures, connectivity measures, and other measures. And I'm going to show you the results. Like I said, we had 16 eligible articles describing 15 studies, and these are our results in a graph. Don't worry, this is really overwhelming and confusing, and I'm not going to go into detail here because this is about EEG, wake EEG, and I know this is the sleep symposium, so if you want to look into the correlations in more detail, you can scan the QR code here. This will take you to this article because it got published last week. So yeah, have a look if you're interested. But what I want you to take from this is that we didn't really find anything. So gray means that this specific correlation wasn't studied, and white means that this specific correlation was not significant. And you can see that there is a lot of gray and a lot of white. The light colors mean that there was one significant correlation, but also the same correlation was found in another study being non-significant. So light green means there was a significant positive correlation, but also a non-significant correlation, and same for red, but the other way around. Purple means conflicting results, and only the bright colors mean that this was a significant correlation where another study didn't find a non-significant correlation. But for the bright colors, this was only the case for one single correlation in one single study. So you can't say that we found a robust marker, because if one single study finds something for one single correlation, this is just one study finding one thing. So yeah, definitely not a marker of cognition. In total, those were 16 significant associations. Most were between ERP measures and attention and processing speed performance. So the top left bit, several within executive functioning and ERP measures, one within working memory and ERP measures, and one within intellectual capacity and ERP measures. So no for connectivity measures, spectral measures, or other measures either. But, like I said, this is all wake EEG. We didn't find a robust marker here. There was no consistent correlation across studies, and like I mentioned earlier, the methodology was not really consistent either. So maybe if in the future studies would use the same EEG measures and the same cognitive tests, maybe that would help us to identify robust wake EEG markers for cognitive performance. But so far, we can't really say that we did find anything. So, do we have more luck with sleep? Are there sleep EEG markers of cognition in bipolar disorder? This is what we're looking at now. Poor sleep is very common in bipolar disorder. It is linked to decreased psychosocial functioning and quality of life, and this may be contributing to the cognitive impairments I mentioned at the beginning of my talk, as they also persist in remission. And I think this association is quite intuitive. Like, all of us probably know that feeling when you had a bad night's sleep or a couple bad night's sleeps, then the next day you don't really function that well. It's a bit harder to focus, a little bit harder to concentrate or memorize things. So I feel like this association is quite intuitive. And one thing to look at here are sleep spindles. They might be like a main mechanism of sleep and cognition. Sleep spindles are brief bursts of oscillatory synchronous EEG activity in the frequency range of 9 to 15 Hertz, although 9 to 15 can vary a little bit from definition to definition. And they occur in non-rapid eye movement, sleep, and are a defining feature of stage 2 sleep, but they also appear in 3 sleep. And they look like this. This is why they're called sleep spindles. And you usually get them with a setup like this. So participants would come into a sleep lab, sleep with a full EEG cap with all the channels, and then you have those sleep spindles when you look at the sleep EEG. Sleep spindles have been linked with general cognitive and memory abilities. There are associations between sleep spindle activity and attention and processing speed and psychosis. We know that there are decreased fast spindle density associated with impaired memory performance in healthy schizophrenia relatives. And we also know that patients with schizophrenia and bipolar disorder show reduced fast sleep spindle density compared to healthy controls. So this might be a link here. So we know fewer sleep spindles per minute are associated with impaired cognition in different samples, and we know there is decreased fast spindle density in bipolar disorder, so this might be a link, but no one actually has looked at this. So this is what we are doing now. Is sleep spindle density associated with impaired cognition in bipolar disorder? And this is the paper we're currently working on, the association between sleep spindles and cognition in euthymic bipolar disorder patients. We're aiming to recruit 36 euthymic participants with bipolar disorder, and they all do an at-home EEG assessment for 3 consecutive nights with mobile EEG devices. We're using Z-Max by Hypnodyne, and this is quite special about our study because this is what our EEG assessment looks like. I showed you a picture of the standard EEG lab setup before, and we are just using these headbands. They have 2 frontal channels and 1 reference channel, and the participants can just take this headband home, turn it on, sleep with it, and then bring it back to us. They also all do a cognitive battery consisting of loads of different cognitive tasks, for example, the digit symbol coding task, trial making task, digit span, hotel test, but many, many other tests as well. And we will then do a FDR-corrected correlational analysis between sleep spindle parameters, for example, and mainly density, but also frequency and amplitude, and cognitive performance, for example, memory and attention, but we will also want to look at the composite score. And you might guess from the way I phrased things that unfortunately I can't show you any results yet, because we're still working on that paper, and the data is part of an RCT, of a bigger RCT, so I can't even get any preliminary data because the data will only be available once the RCT has finished. But I can give you a couple of first insights because we have completed 29 out of 36 participants. So we would say it's quite user-friendly. People, like I said, can just take it home, turn it on, take it back to us. Maybe not quite as user-friendly as we would have liked because they have to press a couple of buttons, and that turned out to be a bit more complicated than we thought. It is home-based, which is a major advantage for both the participants but also the staff, because no staff has to be at a lab all night. We can just sleep. And the participants can just sleep in their own bed, which might make the data a bit more ecologically valid. It is feasible, so we've been doing this for a bit over a year now and have completed 29 participants, which we are quite happy with. The data quality is really good considering that we only have 2 frontal channels. We are currently manually scoring some of the data, and it does take some getting used to, I'm not going to lie. It's quite different from having a full channel EEG, but it is possible and feasible, and we are really happy with the data quality, and you can see the spindles really well as well. Also, we are working on training an algorithm at the moment. There are loads of algorithms existing already where you can just put your EEG data in and they will score the data for you and do the spindle annotation for you. But those algorithms are usually trained with full EEG setups, so they don't really perform that well on our only frontal channel data. So this is why we are currently manually scoring some of the data, because we're trying to train this algorithm on our headband data, and then hopefully all the scoring can be done automatically as well. So we think that this can really be a game changer. The home-based headbands combined with the algorithms would make sleep research on a much larger scale a lot easier, a lot cheaper, and a lot more feasible. So to give you a bit of an outlook, I hope I could show you how we want to, together with EEG, different EEG measures, want to inform cognitive difficulties and shed light on the biological underpinnings and ultimately inform treatment, so that people with bipolar disorder can focus on their book again, go grocery shopping, and use public transport. I want to thank my supervisors for their really, really great supervision, Dr. Becky Strawbridge, Dr. Philip Ritter, and Professor Alan Young. I want to thank the CRIP2 team, which is the RCT I'm working on, with Dr. Dimos Tsapekos and Michael Kaufers, and all the other ones on the team. I want to thank my other collaborators, and I want to thank the IRTG team, which is the PhD program I'm part of. And I want to thank you for your attention, and I'm looking forward to the discussion. Thank you very much.